Hi everyone, we're going to wrap up the course with this last video, which is finishing out chapter 7, and then we'll do one little section of 8.2 as well, and so we're going to put all that together into one video, and then we'll be done with intermediate algebra. So the last thing is a little bit further discussion on radicals. And so if you want to do things like adding or subtracting your radicals, then the radical has to be the same number underneath and the same root. So like you could have the square root of 3 on two different ones and you can add them together or subtract them. Then we just add or subtract the numbers that are in front of the radical. So for instance, on this first one, you have 2 times the square root of 5 plus 7 times the square root of 5. This is very much like if it said 2x plus 7x. The x's don't change. 2x and 7x just is 9x. You're adding the stuff in front. Well, if it's 2 root 5 and 7 root 5, this becomes just 9 square root of 5. But if they don't already match, like in this case, they're both square root of 5, if they don't already match, you have to make them match before you can add them or subtract them together. And that's like on number 2 here, the second example. Negative 9 square root of 3 plus 5 square root of 27. You cannot add them unless they have the same thing. And so it's typically easier to take the bigger numbers and simplify them. So that's what we'll do here. I'm going to take the 27, and 27 is 9 times 3, or 3 times 3 times 3. And I will rewrite this problem as negative 9 square root of 3 plus 5 square root of, and I'm going to take two of these together and make this 3 squared times 3. Because remember, if you have a power on either a x or a number that matches the root you're taking, then you can take that number out in front. And so I can take a 3 out in front. So this is negative 9 square root of 3 plus 5 times 3 square root of 3. So I'm taking this 3 out and moving it out in front. This gives me negative 9 square root of 3, and 5 times 3 is 15 square root of 3. Then I have the same radical with the same number. They both have a 3 underneath. So you can add the numbers in front. The negative 9 plus the 15 gives me 6 square root of 3. So you do have to simplify it as much as possible. So let's do some more like that. Here we have the cube root of 81 and the cube root of 375. So I need to get things that have a third power on them. And again, I'm going to have to simplify these things. So the 81 is 9 times 9, and 9 is 3 times 3, and 9 is 3 times 3. Since it's a cube root, I need a third power, so I'm going to need 3 of them together. So I'm going to rewrite the first one as 2 times the cube root of 3 cubed times 3. 375 is a little bit harder to do, but it's not too bad if you just start dividing stuff into it. Like for instance, it is 25 times 15. And 25 is 5 times 5. 15 is 5 times 3. And again, you need a group of 3 because we're doing cube roots. So I'm going to take this group of 3 5s together and say that this is minus the cube root of 5 cubed times 3. So the ones with the cubes on them, the 3 cubed and the 5 cubed, because it matches on the power with the root, you can pull that base out front. And so I'll have 2 times 3 times the cube root of 3 minus 5 times the cube root of 3. Or 2 times 3 gives me 6 cube roots of 3 minus 5 cube roots of 3. They match, the radical does match, so you just add or subtract the numbers in front. 6 minus 5 is 1, but we typically don't write the 1 in front, so we just say 1 cube root of 3 is just the cube root of 3. Then I'll do the same thing on the second example. 72, I know 9 times 8 is 72. 9 is 3 times 3. 8 is 2 times 4, but 4 can also be 2 times 2. Here I'm doing the square root, so I need things to a second power. So this 3, there are 2 3s I can put together, and 2 2s I can put together, but I still have one left over 2 as well that will stay underneath the radical. So this will become 3 times the square root of 3 squared times 2 squared times 2. The 32, I could do a few different ones. How about 8 times 4? 8 times 4 is 32. 8 again becomes 4 times 2. Now at this point right here, you could quit because I have a group of 2. There are 2 4s. At this point, I could use this 2 and this 2 together. And so I think I'll just stop there. You could keep going if you wanted to. But I'm going to make this, oops, not an equal sign. I'm going to make this be plus 3 times, and I'm going to write this as 4 squared times 2. And then the 8 is 4 times 2, or 2 times 2 times 2. I need a group of 2 to pull in front, and that'll leave me 1 2 left over. Notice, if you have 1 2 left over on the first one, you should have 1 2 left over on all of them, or you won't be able to add and subtract them. So I'll end up with a minus, I'm going to kind of write this underneath it, minus 7 times the square root of 2 squared times 2. So all of those powers that match the square root, I can pull out front. So this will become a 3 times a 3 times a 2, oops, times the square root of 2. Like I said, I'm pulling the 3 out in front and the 2 out in front. Then I can pull this 4 out in front and say this is 3 times 4 root 2. And then I could pull this 2 out front. Minus 7 times 2 root 2. So 3 times 3 is 9 times 2 is 18. So I'll get 18 square roots of 2. I'll get 12 square roots of 2. And 14 square roots of 2. So 18 minus 14 gives me 4. 4 plus 12 is 16. So I get 16 square root of 2. Or if you want to do 18 plus 12, that's 30 minus 14 is also 16. And that would be my answer. But the main thing is you got to simplify it to be sure that the same number is underneath the radicals before you can add and subtract them. Now, when we multiply and divide, we kind of talked about multiplying a little bit on the last video, but that was really multiplying if you didn't have anything added or subtracted to it. Here you have things that are added or subtracted, like root 3 plus 7 times root 3 minus 7. This idea here is exactly like FOIL that we talked about a few chapters ago. I FOIL it. That's all I'm doing. And so when I FOIL it, I'll do the first ones the way they are. That'll give me the square root of 3 times the square root of 3. And remember, when we did that in the last video, the very end of the last video, I said all you have to do is multiply your radicals together, your numbers underneath the radical, to get square root of 9. Then I would do the outside. The 7 and the root 3 don't really have anything in common. They don't have a radical on both of them. So we just write it basically the way it looks, 7 times root 3. The inside will give me a positive 7 root 3. And then the last one's 7 times negative 7 is negative 49. Notice the ones in the middle actually cancel, and so I'm left with the square root of 9 minus 49. But the square root of 9 is 3 because 9 is 3 squared. So this gives me 3 minus 49, which is negative 46. Sometimes you end up with no radicals left in the problem. That's not really the normal thing that happens. Usually you end up with a radical in it. This one just doesn't, because that's technically the difference of squares. And so if you remember the difference of squares formula, the middle term always cancels. The second one is actually that perfect squared trinomial I kind of made mention of back when we talked about foiling. But you can also do the same thing as we did back then, as just writing this down twice. And FOIL it out. If I do the first one, 8 times 8, that is 64. The outside, 8 times the square root of 10, is literally just 8 times the square root of 10. The inside will actually give you the same thing. And the last ones, root 10 times root 10, will become square root of 100. So here the 2 in the middle don't cancel, but they still combine together. This is 16 root 10. And the square root of 100 is the same thing as the square root of 10 squared. The squared and the square root cancel to give you just 10. So I'll get 64 plus 16 square root of 10 plus 10. So that gives me 74 plus 16 square root of 10. Again, here we don't have the ability to get rid of the radical, and that's okay. Now, when you divide by a radical, that's called rationalizing. So if you rationalize, you are trying to get rid of the radical in the denominator of a fraction. We have really two ideas. You could have just a radical like square root of 11 or square root of 3 like we have in our examples, but you could have things like 3 plus square root of 11. We won't do those. Those will be covered at the very beginning of college algebra. So we're going to do kind of the simpler ones where we just have square root of 11 or square root of 3. What you want to do is we're going to multiply the top and the bottom by whatever the radical is on the bottom. And so I'm going to multiply the top and the bottom by the square root of 11. What that will do is you'll end up with 11 times the square root of 11 over the square root of 121. The 11 times the 11. Now you can't multiply the 11s together on top because one's inside of a radical and the other one is not. But the two radicals on the bottom you can. And that actually becomes 11 squared. So the square root and the squared cancel each other. So you're left with just an 11 on the bottom. And there's an 11 on top. Those 11s can cancel. And your answer is the square root of 11. So if you divide 11 by the square root of 11, you'll end up with the square root of 11. That's just like when you divide 4 divided by 2, you end up with 2. On the second one, I'm going to do the same thing. I'm going to multiply by the square root of 3. Whatever's on the bottom, that's what you multiply by. And so on top, they both have radicals on them, so this becomes square root of 30. And on bottom, this becomes square root of 9. The square root of 9 is 3 because 9 is 3 squared. And the radicals cancel to give you square root of 30 divided by 9. 30 does not simplify very well. It is 6 times 5 or 3 times 3. Oh, 3 times 2, sorry. 6 is 3 times 2. 3 times 2 times 5. And so none of those will have a squared in them. So that's perfectly okay just to leave it like that. So now we're going to jump into 8.2, which is basically the quadratic formula. And so you've probably seen the quadratic formula in some other course somewhere along the way. This formula is used for when a quadratic equation will not factor. And a lot of them don't factor. Even if it does factor, you could still use the quadratic formula. The quadratic formula can be used anytime it either factors or doesn't factor. But if it doesn't factor, definitely use the quadratic formula. So what we want to do is we get it into this form right here. This is the form we're aiming for. You got to get it into an a squared plus ax squared plus bx plus c equals 0. You have to get it equal to 0 first and put it in descending order. Then that a, b, and c go into this formula down here at the bottom. And that is the formula. X equals the opposite of b, or negative b, whichever one, plus or minus the square root of b squared minus 4ac all over 2a. There's usually a rhyme with that if you want to like look up one of those, or you might know one. You might be singing it right now. I'm not going to sing it because I never learned it that way, and I don't really know one off the top of my head. But you could like go to YouTube and see one as well. So we're going to use that formula to solve some problems. So for instance, this first one is already in the correct form. It is equal to 0 and it is in descending order. So I'm going to write my formula up here on the top right here. My answers are the opposite of b, plus or minus the square root, b squared minus 4ac all over 2a. So that's my formula I want to use. So in this problem, this 2 right here is my a. The negative goes with the 13, so negative 13 is my b. The negative 1 is my c. And basically I just plug them in that formula and see if it simplifies. So x equals the opposite of b, so that would be negative 13, plus or minus the square root of b, which is the negative 13, squared, minus 4 times a, which was 2, times c, which was negative 1. All of that gets divided by 2 times a, which was 2. And sometimes this simplifies and sometimes it doesn't. But what we'll be left with on top is a positive 13 plus or minus the square root of 13 squared is 169. 4 times 2 is 8, so I'll end up with a plus 8 all over 4. And so x will be 13 plus or minus the square root of 177 all over 4. Then you have to decide, can you simplify 177? It is 3 times 59, but 59 does not simplify at all. And so, no, you really can't simplify it. Now on the homework, what they'll probably want you to do is, you'll see it in a blank. You'll see a big blank in between a set of braces. And so what they'll probably want you to do on the homework is to write 13 plus the square root of 177 over 4, put a comma, and then 13 minus. I don't know, they were working on updates and they may have put a plus minus button in there. If they didn't, you can just split them up with a comma. If they did, use the plus minus button. Now, this one doesn't have any of the right form. It's not in descending order and it's not equal to 0. So the first thing I'm going to do is add the 7x, oops, not negative 7x, add the 7x to both sides. and make it be x squared plus 7x equals 5. And then I'll subtract the 5 from both sides. And as I'm doing this, notice I'm putting it in descending order. So I have x squared, 7x, and minus 5. That is in descending order, and it's equal to 0 now. And so at this point, notice I'm going to do the quadratic formula. I'll write that down up here again. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. My a value here is the number from the x squared. That's an understood 1. My b value is the 7. My c value is the negative 5. And so I will say that x equals negative b is 7, plus or minus the square root of b, which is 7, squared minus 4 times a, which is just 1, times c, which was negative 5. All divided by 2 times 1. And then we simplify it, or at least we hope we can. This is negative 7 plus or minus the square root of 49. And 4 times 5 is 20, so I'll have a 20 here, all over 2. Or that's negative 7 plus or minus the square root of 69 over 2. Now 69, we have to check, does that simplify or not? It is 3 times 23. 23 does not simplify any more than that. And so you're basically done. So at that point right there, this would be your answer, unless you had to write it as 2 separate answers, with one being positive and then comma, one being negative. So you may have to split them up like that. Oops, I erased the 6 by mistake. Okay, let's try this one. Again, almost in the right form, not quite as bad off as the last one. This one I only have to subtract the 65 to the other side. And so I'll end up with x squared minus 8x minus 65 equals 0. So again, using the same formula, opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. Just like on the last one, my a value is the understood 1 in front of the x squared. My b value is the negative 8. My c value is negative 65. So I will say that x equals opposite of b being the negative 8, then plus or minus the square root of b squared, so I'll get a negative 8 squared, minus 4 times a, which is just a 1, times a c, which was negative 65. That's actually kind of a big number. All divided by 2 times 1. And so we look and see what happens. So we'll end up with a positive 8 because the two negatives cancel. 8 squared is 64. Negative 8 squared is 64. And then I'll have 65 times 4, which is 260. All divided by 2. So I got 8 plus and minus 260 plus 64 is 324. Oops, 324. And I believe 324 does simplify. 324, yes, it is 12 times 27. So we are going to probably have to simplify this one. So I'm going to go up here to the top right and see what happens. So if I take this 324, it is 12 times 27. But 12 is 4 times 3, or 2 times 2 times 3. 27 is 3 times 9, or 3 times 3 times 3. I'm doing a square root, so I need a group of 2. My groups of 2, I would have a group of 2 2s, a group of 2 3s, and pairing these two together, I have a group of 3s as well. I used every number, which means actually the square root of 24 is a perfect square. If you didn't notice that, I did not notice that, and so that's perfectly okay. This is, down here on the bottom, this is 2 squared times 3 squared times 3 squared. Or it is 2 times 3 times 3. Or that's 8 plus and minus. 3 times 3 is 9 times 2 is 18. So I bet if you typed in 18 squared in your calculator, I bet it's 324. Hey, it is. Look at that. What that means also is that we didn't have to do the quadratic formula on here. It was possible to come up with two numbers that multiplied to 65 that either added or subtracted to 8. And if you see that, you could do that way if you wanted to. Apparently, I did not see that though. And so, I'm going to kind of go right above this. Since it does come out to a whole number, what we would do is we would say that x equals 8 plus 18 over 2, which would be 18 plus 8 divided by 2 is 13. And then we would also do 8 minus 18 over 2. 8 minus 18 is negative 10 divided by 2 is negative 5. So your answers here are 13 and negative 5. So if you were to come up with that factoring wise, two numbers that multiply to 65 that add or subtract to give you 8 would be 13 and 5. But like I said, you can always do the quadratic formula. Okay, this one's probably like worst case scenario. It is totally in the wrong form. It is so much in the wrong form that we're going to have to do some foiling and all sorts of stuff to get it into the correct form. So the left-hand side, that is the same thing as 4x plus 3 times 4x plus 3. I have to FOIL those two terms together before I can subtract the 17x and the 11. So if I FOIL them, 4x times 4x will give me 16x squared. That's the first one. The outside will give me a 12x. The inside will also give me a 12x. And the last ones will give me a plus 9. So if I were to add those together, I'll end up with 16x squared, 24x, and 9. Then I can isolate this stuff. I'm going to subtract the 17x from both sides, and I'll go ahead and do both steps at once. I'm going to go ahead and subtract the 11 over as well, so that all that stuff will cancel. And I'm left with 16x squared. 24 minus the 17 will give me 7. And 9 minus 11 is a negative 2. Now we have it in the correct form. Descending order equal to 0. And so I'm going to use my same formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. In this case, the 16 is my a, the 7 is my b, the minus 2 is my c. So I'll put it up here on the top right. So x would be equal to the opposite of b, which is on 7, plus or minus the square root of 7 squared minus 4 times a, which is 16, times c, which is negative 2. All divided by 2 times a, which is, again, 16. This will leave me with a negative 7 plus or minus the square root of 49. And I don't know what that other part is, so we're going to go to the calculator for a moment and go 4 times 16 times 2 is 128, it looks like, unless I typed it in wrong. And 16 times 2 is 32. So then I just have to add the 128 to the 49. And hey, I've seen that number before. We get negative 7 plus or minus the square root of 177, like we did on the first one, over 32. I already know that 177 won't simplify because it didn't on the first example, so it won't here as well. And so that would be your answer unless you have to split it up into two different ones, one with a plus and one with a minus. And so those would be your answers. And that is the end of intermediate algebra. So hopefully this went pretty well. And yeah, that's about all I got. So hopefully you enjoyed the class, learned something, and do well on your final, and you'll be great.